recording. So I'm gonna record. So welcome to our intro class. I'm going to start recording. Quick, the question was about lab 1166. It is a lab that does not require NetLabs. And if you want to get to the document, you can go into the curriculum, click on the course index, uncheck all, check labs only, and lab 1166 will show up down here. It's a lab that you use just the written portion to do the lab. Okay. Right. Go ahead. Second question.
For the students and instructor IP addressing workbook. So I just downloaded them to my PC. There's nothing here to do other than understand how that works, correct?
Right. Yeah, that's just there for you if you want to use it. It's something we use for our students sometimes if they need extra work.
Okay.
It's not for you to, like I said, you don't have to do anything in it. It's just a good document to share, especially if your students are struggling with subnetting.
Right.
And then the instructor workbook just gives you the answers.
Okay, good. All right.
And
I had a question real quick, if you don't mind.
Yeah, go ahead.
So I know we have to do a certain percentage of these labs and the packet tracers and stuff.
Yep.
Now I had a question about the packet tracers and stuff that you don't really actually do anything. It's just kind of, you read through them and you do it, and they kind of have some questions and stuff. Yeah.
Yep.
How exactly do we do those, and like what do we turn into you for that? I know you said something a ways back, but I don't remember where you said it, and I couldn't find it.
You still just put your name in front of it and upload it, even though there's nothing really to upload.
Okay.
So just put your name in front of it, upload it, and that lets us know that you've gone through it.
Okay, awesome. Thank you.
What I converted those PDF files to a Word file, and then I went into the lab and answered all the questions and added back to that file and uploaded it back into the system. That's
perfect. That works perfectly too. If there are any questions in it, what Michael said there, Christian, a good thing to do is upload the questions with it by converting it. But we know you're not going to be able to do a check results or show a check results or anything because there's nothing there to check. They're just look and see packet tracers.
Okay. Yeah. I've been answering the questions. It just feels like there might have been a faster way of like submitting it.
Unfortunately, no. Unfortunately, no. And again, remember everyone that as far as completion of this course, we expect you to do all the chapter or module exams. So you got to do all the module exams, 80% of the packet tracers, which is roughly 25 labs, and the packet tracers. So 80% of the packet tracers and labs. We expect you to make a 75 or higher on the final exam. And there's, again, you get multiple choices if you don't do that, but you will hopefully do that on the first choice. And then there is going to be a hands-on skills exam that is inside of NetLabs that you will have to do. So that's one of the reasons why today I'm actually going to take a few minutes. I'm going to back up and punt a little bit. I was going to do our subnetting today, but I have noticed through grading, by the way, a lot of grading has taken place over the past couple of days, that many of you are not at the point of being in modules 11 through 13 at this time. So we're actually going to be, I'm going to go over the lab for chapter 10. So to build a switch and router network, I'm going to do that lab instead of trying to move forward, simply because I don't feel like many of you are at the point to where you've read that material yet. So I want to make sure everybody's read 11, 12, and is ready to go over it before we try to do that. So I'm going to back up just a little bit, and we're going to go back. And since this is Wednesday and it's typically a lab day, I'm going to go over a lab. But let me ask you again, are there any questions before I start the lab? Any questions at all? I know a couple questions there at the very beginning from Michael. Any other questions from anybody? I see. Is there anything in chat here, Michael? Back. Okay. Yep.
What lab you about to do?
We're going to do lab 1044.
1044. Okay, good.
1044. And what there's a reason I'm doing this lab, and that is because it is extremely important that you can do what's in this lab. Because you may see something very similar somewhere else down the road. Rashad, I'm gonna put you. Okay. And so take that as the hint. It is. I just mentioned to you that you have a skills-based hands-on final. And so that skills-based hands-on final may look similar to something you're seeing today. So just a little hint there. So what we've got in this lab is we've got 2 PCs and a switch and a router. And I'm going to start with the simple stuff first. I'm going to go on in and I'm going to, I've got to get in here and change these because it's driving me nuts. 1024 by 768. It's multiple attempts, but you should be able to get it done in one, I would think, Christian. It's really not that bad once we get you going on it. You'll see, especially once you get your do some practicing. Also, by the way, I've been looking at most of the labs, and most of you are doing a really good job and are doing labs on NetLabs. There were a couple labs that you did that were like using the wired and wireless NIC. Some of you used your own equipment for that, which was fine. But we do expect you to be doing your labs on NetLabs. So be aware of that. We do want you to do them on NetLabs. So I'm going to start out in here. And by the way, normally I would say read everything very closely. But I know from this lab, I've done it in the past. So I'm just going to put IP addresses on this ncpa.cpo. I believe I got that right now. Finally learned. Karen taught me something. So I'm going to PCA and put an IP address on here. And I'm going to put, let's see, this one's 192.168.1.3. And I'm going to do my sub default gateway 192.168.1.1. Okay.
Hey, Kelly.
Yeah.
Hey, your screen isn't showing.
What? You got to be kidding.
When you started recording, it defaulted to turn that off.
All right, here we go. So now I'm back in here doing the lab. So again, here's our topology. So be aware, this is something you may see again. I'm setting an IP address on. Now I just set the IPv4 address. So I've statically assigned it to 1.3/24. The 1.1 is the mask. And now I need to statically set an IPv6 address. So to do that, if you've never done this before, you just double click on IPv6 and you assign the IP address. So in this case, I'm going to put 2001:DB8:ACAD:1:1:3, and it's a /64. So you just put 64 down there, and then we're going to use the link local address of the router FE80::1, and that'll be the IP address, the link local we're going to put on R1's, both of R1's interfaces.
So did you just come up with that?
No, it's right here. It's right here on the lab. 2001 DB.
Okay, I got you.
ACAD.
Okay.
Now we will teach you how to subnet IPv6 later on in the class, which is super, super easy. When you start subnetting IPv6, you're going to be like, why do we not use this long ago? Because it is so much easier than the other. All right. So now on PCB, let's do 192.168.0.3 and /25 192.168.0.1. All right, click OK. We'll do our IPv6 address. And let's see, this is 3. Actually, they're using 0. So 2001:DB8:ACAD:3, which, by the way, there's actually 3 colons in there because they're skipping. Actually, there's 2 colons. No, there's 3 colons. 2 colons. So they're skipping the 0. There's a 0 in there that you're not seeing. And then FE80::1. Now that's a little confusing because you think you're the default gateway, but I'm going to show you when you do IPv6 addressing, you actually use the same link local address on all the interfaces on the router. But we've now set the IP addresses on PCA, PCB. The very first item that's talked about here is how do you get a 2960 switch to support IPv6. Now, show SDM prefer. We'll show you what is preferred. You'll notice that this is currently using what's called the default template. The default template does not support both IPv4 and IPv6. It only supports IPv4. So what we need to do is we need to set up or change the SDM template on this switch. If you do not do this, you cannot put an IPv6 address on the switch. It will not support IPv6. So we're going to go into global config and we're going to do SDN prefer, and I'll show you our different options. Okay. And so we have the default, we have dual IP4, IPv6, LAN-based routing, which actually lets it do routing. If you do LAN-based routing, you can turn the ports into routed ports. So you can do no switch port and turn a port into a routed port. And then there's a QoS bias that I have no clue what that does because I've never worked with it. But we're going to do dual IPv4, IPv6, and you got to put default. All right. Now, once you do that, you must reload the system in order for that to take place. I'm going to save it and reboot it. So now we will end up, when it reboots, I'll do a show SDN prefer, and you'll see that it now supports both IPv4 and IPv6. Thankfully, the router already supports IPv6. So if you go into the router and do a show ver, you'll see that it's an iOS version that supports IPv6 out of the gate. So first items, configure the IP address and mask on the PCs. And it's going to say, can you ping from PCA to PCB? Well, that, I hope you know, it's not going to work, because without the router being configured in the middle, there's no way to get from PCA to PCB. So I'm not going to do this ping because it will be unsuccessful. But let's move down and configure the router. The router configuration is very simple. If you have done a switch configuration, then you know how to do a router configuration. First, we go into global config, give it a host name. All right. I'm going to do a no IP domain lookup. And that turns off DNS lookup. That keeps you, when you type the wrong thing, it won't sit there and try to do a DNS lookup. I'm going to go ahead and go into line con 0, do login synchronous. And then I'm going to do password of Cisco. And I'm going to do login. I'm going to do line. Now here's a little bit different for VTY 04. We use 04 instead of 015 on a router. Hit the up arrow, be lazy. And now we've assigned Cisco to the console and to the VTY lines. We need to set our enable secret password. Now, I don't have to drop back to global config to do enable secret. I could have just typed it right there if I know the command. So let me go back in there and do that. Line con 0. Okay, so I'm here. If I know the command, I can type enable secret class, and you'll notice it takes the command. It drops me back to the mode that I'm supposed to be in. So just be aware, you don't have to go back and to the modes. You can, as long as you know the commands, most of the time you can enter the command and it will work. I need to encrypt plain text passwords. Somebody tell me what's the command to encrypt all your plain text passwords. Right now, if I do a do show run, look what happens. You could shoulder surf me and you can see what the passwords are on the console and VTY line. How do I stop that?
Service encryption.
Service
Really
password encryption.
Yeah.
Service password encryption.
Yeah.
Okay. So now if I do a do show run, you'll notice they're encrypted. Now, again, this is not strong encryption, but it's good enough to protect you from someone shoulder surfing and seeing it. Now I need to do a banner. So banner MOTD, some delimiter, some start character. I almost always use the pound sign. And then we use a little ASCII text here. And what's the purpose of that delimiter? Anybody remember?
If somebody accidentally gets in there or on purposely gets in there, you can take it to your attorneys. They can deal with it.
That's the purpose of the banner itself, but this delimiter character, what is it doing for me?
Tells you when to start it and where to stop it.
Yep, exactly. When to start the banner message of the day and when it ends. So if I put the next time it sees a pound sign, it knows that the banner is over. By the way, this is a terrible banner.
Enter to get to the next line.
Yeah, it's really cool. I mean, it's a cool banner. You shall not pass, flame of Arnor. Anybody know where that comes from? Oh, come on. Somebody's got to know that. You shall not pass. Do what?
Lord of the Rings.
Lord of the Rings. Oh, awesome. Okay, whoever that was, you passed. Who said it? This is actually,
Which was the right answer.
But remember, this is the extra stuff I give you for free. That's Gandalf, and he's in Moria. So that's how I'll do it. Mike, you were asking how you're going to do the next line with stars. I just hit enter and do stars for the next line. As long as I don't put back in the delimiting character, it will let me put in pretty much whatever I want. So let's see here. Activate both interfaces on the router. So what I need to do is go up here and see what the IP addresses are they want on me. So let's do interface GI001. All right. I want the IP address of 192.168.1.1, 255.255.255.0. By the way, what the /24, do you understand that means 24 ones in the subnet mask? That's what that means. So that's why I'm using 255.255.255.0, which that is part of the next chapter we're reading. All right. How do I activate this interface? Anybody know?
No
No shut. No shut. Yep. By the way, another key difference between routers and switches. By default, switches, when they're shipped, the switch ports are turned on. So if I go back to the switch right now, okay, I forgot to hit reload like a doofus. Okay. Eventually, when it comes back up, I'll show you, but they'll all be up. Ports on a router are down by default. So if I go right now and do a do show Ipm brief, you will see that they're down. Okay. They actually should have been administratively down. Typically, they're administratively down by default. Okay. So now let's do I got to do my IPv6 address. 201:db8:1:1/64, and then I got to do IPv6 address FE80::1 link local. Now that's my link local address, which is only used on local communication on that side. A lot of people get confused. They say, well, how can you use the same link local address on both interfaces? Well, it's only a locally significant address, so it doesn't matter. So I'm going to change this to 3.1, and notice how, or 0.1. Notice how I just use the same commands over again. I don't retype stuff. I'm lazy. As long as you can remember where you're at, you're good to go on that. So now let's do a, looks like I got all this. Now I need, very important is this command right here. Without this command, the router will not route IPv6 between its interfaces. So you have to turn on IPv6 unicast routing. So IPv6 unicast routing. Now I'm by the way, you want to do something really evil to somebody? Do that command right there. That's an evil command. So should be IP, maybe IP routing on this one with the new system. Yeah, it's IP routing. So you can actually do no IP routing, and that will turn off IPv4 routing, which is very, very evil. But now let's do this. Let's do a do show Ipm brief. And notice I have on my gig 01, I have the IP address 192.168.1.1, which is correct. On my gig 0, I have 192.168.0.1, which is correct, and they are both up. And then I can do a do show IPv6 int brief. And you'll see I screwed something up. Yep, sure did. I did not get the right. I did not put my IPv6 address on gig 00. So yeah, that's why you check, folks, so you don't make dumb mistakes. IPv6 at 201. ODB 8. Oh, 8 3/64. Not 3, 1. 1. 4. Now let's do a duo show IPv6 in brief. All right, so now gig 00 is FE80::1, link local. It's only locally significant, so it can be on both gig 000 and 001. 2001 DB8 ACAD::1. So this is the 0 subnet, and this is the 1 subnet of the 2001 DB8 ACAD/48 network, or prefix. But you'll notice they're both up. All right, so let's look here. What else we got to do? Configure, activate both interfaces. Done that. Now set the clock on the router. Now this is type clock set question mark. You'll notice this is the weirdest thing. This is a command that is not in config mode. So even though I'm not in global config, I can do clock set and I can set the current time. So the hour is, let's see, 16:46, no, 16:26:32. And we got to do the month, which is 7. Oh, no, day, which is 6/7/2022. Got it. And again, you got to do it exact. You got to do July, and then the year. All right. So now, why is it important, by the way, you set the clock?
A lot of your services are running off of that clock.
A lot of your services. You'll notice here. Look at this information message. It tells you on July 6, 16:26:32, the clock has been set. So all of your messages from your routers, all the login information of people logging into your devices, it's very important in your network. And they don't stress this enough in our class, but it's very important over your entire network that you have an authoritative time and that it is set on all your devices. If someone breaks in your network and your clock or your time is set, now watch it. Let's do this here. Let's see if we can do show clock. Okay, so see, this is saying that my switch is in 1993. So if someone breaks into this network and defaces or destroys this switch, and my messages from the switch are from 1993, and we go to court and try to press charges against someone, it's going to immediately be thrown out, or should be thrown out, when the person's able to say, well, your honor, my client wasn't born in 1993. Bingo. Okay, great. Thank you very much. Come again. So it's very important that you actually do set your keys or set your clocks on your entire network correctly. We don't go over that a whole lot, but it is something that is important. I will say at this point,
do they not have a set clock server like they do in Microsoft? They'll have a set server that's
yeah, you can do an NTP server. You can do an NTP server, which is easy to do. But all right, so let's do this. Let's go ahead now and let's test our pingage. So can we ping from here 192.168.1.3 over to PCA? Yep, sure can. Now, how about IPv6? Ping 201:DB8:ACAD::. I gotta go back up and look because I don't remember what it is. PCA is 1:3:1:3. And we get a reply. So I have full pingage between PCA and PCB on a very simple network. Now let's go down here and look at a couple more things. Now we need to configure our switch. So again, let me show you how fast you should be able to do this once you really know what you're doing. S1 enable secret class. Oops, class on 0 login synchronous. Pass this down. Service description banner mode OTD, boom, stay out. I'm doing very simple banner there. All right. Now we do need to set our VLAN interface. So let's do no IP domain. Now, one thing's here, notice how the command was different on the switch than the router. On the router, it was no IP domain space lookup. On the switch, different iOS version, it's no IP domain dash lookup. Be aware it can be different based on the iOS version. So that's aggravating, but it is what it is. All right, so let's go give our switch its IP address. So we go to interface VLAN 1, which we've done before. VLAN 1 IP add 192.168.1.2.255.255.0. Okay. And then we're going to do, we need our default gateway. So we're going to exit here. IP default dash gateway 192.1. Can't type 168.1.1. Okay. And that's so that because of where the router is or where the switch is at, it needs a default gateway in case it needs to get over to PCB. So let's go to PCB and ping 1.2, which is the switch. And we'll probably get a failed and then 3 good ones. And it's doing that because it's trying to find the MAC address table and get everything cleared out. There it goes. Failed twice and then worked. Okay, so now we have pingage from PCB over to the switch. Now at this point, we have pretty much configured everything that we need to do, and we have connectivity.
Hey, Kelly.
Now, yeah.
Hey, we had a comment about, I guess they're asking if you should save the config then.
Yep,
Save.
very, very good. Very, very good. Yeah, I should do a write or a copy run start. WR is the extreme short version of copy run start. So I should probably do a copy run start. Okay. Yep, that is a very good one, because if the power went out or if the routers were to, the items were to bounce, I would have lost everything I just did. Yeah. Notice some commands I want you to show here, show IP route. And you can see our connected and our local. So this is the network that is connected to that interface. And this, the L, is the actual IP address on that interface. If I do a show IPv6 interface, you'll see it give me interface information about IPv6. You can see it's enabled. Link local address is FE80::1. The global unicast address is this. Notice here's those, we talked about those multicast address. Here's those multicast groups it's joined right here. And then gig 001 is also using the link local address of FE80::1. And it has the global unicast address of ACAD1::1. Now we should be able, and they don't give you an IPv6 address for switch 1, but let's see if we can't put it on there. Should be able to. Yep, VLAN 1. IPv6. Yep. 1:ACAD:DB8:ACAD, and it is on the 001 side, so it's on the 1::. Let's just do 10 just to get it out of the way so we know it's up there above. Okay. And IPv6. Okay, so now let's see, we should be able from PCA to ping. So let me do this so we can see it better. By the way, if you ever get it's a little bit blurry like that, you can always say actual size and it usually clears it up a little bit. Ping 2001:DB8:ACAD:1:10. Yep, there we go. So we're getting a ping reply from the switch. I'm gonna try it over here. Let's see if I can ping it from over here. May not be able to because need to set the second. I'll do a second. Any questions?
I
Any
guess my
questions?
question is, you finished this in 15 minutes and it took me 2 hours.
No. Yeah, it should be, this should be actually eventually receiving the information so that it can ping over to it. I will tell you this though, Karen, you got to understand, I've done this a while. So this is something I've done a great deal of, and that's, they go down here and try to teach you the different commands too. So show IPv6 route, show IPv6 route, and you'll see that we are connected to these networks, and then our local addresses are the actual address on the interface itself. Yeah, exactly. Alexis, it's a learning curve. Just the more you work with it, the better you'll get. And then if you want to do find the MAC address, show interface G001. This is how you can dig deep in the weeds on an interface. By the way, if you show an actual interface, it will tell you the MAC address of the interface. It will also tell you the MTU. This is something real world that sometimes can bite you in the tail, especially if you're doing any type of VPN tunnels and those types of things. It will also show you different items about the bandwidth of that interface. This is a gigabit interface, whether it's not running it, what it's running in full duplex. Even though it's a gigabit interface, you'll see it's running at 100 megabits, and that's because it's connected to a switch that is 100 megabits. And you get other things down here like, by the way, runts, collisions. So down here, if you start seeing runts or collision, runts typically are from collision, so you know there's a big problem. These things should be pretty clean down here. You shouldn't be seeing collisions. You shouldn't really be seeing runts or giants. If you see a bunch of giants, that could happen if an interface is connected to a server that's got jumbo frames turned on. I did want to show you this, show Ipm Brief. You'll notice that all these interfaces by default are set to be up. You know, they're down because nothing's plugged in them. But on a router, typically, when you do a show Ipm Brief, any interface that's not used is typically set to administratively down. Now, if I want to shut an interface down, by the way, how do I do that? So let's say I want to shut down gig 000 for some reason. How would I shut that interface down?
Just type shutdown.
Yep, type the shutdown command. Shut it down. Well, if I can spell it, okay. Now if I do show Ipm Brief, you'll see it's administratively down, and that's the state ports typically are on a router when a router first boots up. No shut, we'll bring it back up. Sometimes you have to do a shut, no shut to clear out things on an interface. All right. If the interface, and that's where it is, was administratively down, what command would you use to bring it up? The command would be no shutdown. What would happen if you had incorrectly configured the IP address on the router with an IP address of 1.2? Well, first off, communication would break. If you wanted to fix it, let's say I'd accidentally put, and I'll do it on 001. So let's go int G001. What if I had put the IP address of 192.168.1.2? 2.5, 2.5, 2.5, 2.5. I do a do show Ipm Brief. First off, we're going to get a duplicate IP address. But if I did that, if I accidentally put the wrong IP address, you don't have to do a no IP address and take that address off. You can just replace it. IP add 192.168.1.1. Oop, but you got to do 255. I really wish they would put in the ability to do this, but they don't. You can't do that. I wish you could, though. Not on this iOS version. Okay. Do show Ipm Brief. And now you'll say I'm back with the right IP address. You also notice that when I did put in the wrong IP address, it told me that there was a duplicate, and it told me who was sourcing that. Okay, because that was the same IP address set on one of the PCs or on the switch. Okay, so it's telling their duplicate IP address found. So this was a very fast, easy configuration. You'll notice again, if you can do this, you're getting really close to being able to do our hands-on final. There's going to be some other things you got to do, like subnetting. You will have to subnet yourself. We're not just going to give you the IP addresses. But this is a simple lab. And notice how easy it is. Once you know how to configure a switch, how easy it is to configure a router. It's not difficult at all. They basically are the exact same commands, just with slight differences between them. Karen, you are going to have to use VLSM. It will be a VLSM subnet, not a regular, not just regular, not classful subnetting. It will be classless or VLSM. Okay. Now, there is one other thing you're going to have to learn how to do, and I'm going to show you that real quickly, just because we are going to set this up, but you're going to have to set up SSH because we don't want you telnetting. Right now, I can telnet actually from PCA over to the switch or to the router. So I can go in here to PuTTY, find my PuTTY, and I can actually telnet to 192.168.1.1. It's going to ask me for the password, which was Cisco. And you can see I'm in my router, but we all know that telnet is evil. It's of the devil, and you never want to use it. So to configure SSH, I'm going to just throw in the commands real quick. I'm actually going to I'm going to use my holy notepad. Y'all know how I love notepad. So to configure SSH, and this is something we learn in chapter or module 19, you have to set your domain name, create a local user, set BTY line to use local user database, and accept SSH connections. And then you need to generate your RSA keys. Okay, this is all the things you have to do. So let's do that on R1. First off, going to config T. You have to also set your host name. They don't normally tell you that, but the host name has to be set because the host name is used as part of your default to generate your keys. We'll do IP domain name, and let's just say cisco.com. Okay, and then we're going to create us a local user. So user admin password Cisco. Then we're going to go in, I'm going to go ahead and generate my keys. So generate crypto key generate RSA. It's going to ask how big you want it to be. We typically use 1024. By the way, just for the record, if you do like 4096 on a Cisco low-end PIX firewall, it'll lock it up for about 5 minutes while it's generating its keys. Learn that the hard way. B2I04. And then we're going to do login local, which has it log into the local user database. Now, you must have a local user account created. If you do this and you put login local, especially if you accidentally put it on the console port, you are locked out of your device. So don't ever do this on the console port unless you've got a local account made. And then finally, we got to do transport input SSH, which allows it to receive SSH. Now at this point, we can go back to PCA and we can open PuTTY and we can tell it we want to do SSH to 192.168.1.1. It's going to say the server's key is not cached. Do you want to cache these keys locally? Yes. So in other words, the public key for this SSH connection needs to be cached locally. So we say yes. And now I'll log in as admin with a password of Cisco, which is what I used. And you'll notice I'm now in the router and I could do enable, put in class, and I'm now fully in the router with SSH. So this is one other thing you'll have to learn to do for the hands-on. And that will ensure that you're able to to get in, and no one can sniff your passwords as you're going across the network. But other than that, and a little bit of subnetting, once you know how to do this, you're in good shape for our hands-on test. Any questions? No questions whatsoever? And Karen has posted Take a Cat on YouTube, which has got a real good, I think that's one you gave me, Karen, that has the, where they go through every single packet tracer. And I think that's a good thing. If you have trouble, you can use that. He's got several playlists. He actually has a playlist for CCNA 1, CCNA 2, version 7, and CCNA 3, where he walks through every single packet tracer. Just please try to do the lab first on your own before you you do it. Have them walk you through it. Okay. By the way, I will show you pinging the switch IPv6 did work. It just had to took you a little bit to learn its default gateway. You don't have to set an IPv6 default gateway on a switch. It will learn it itself through a router advertisement using ICMPv6, which is what we talked a little bit about when we were talking about finding the MAC address from a known IPv6 address. But it uses that same process to get itself the default gateway. Any questions on this lab? It's a very, very good lab because it has you redoing everything you learned for the switch, applying all that to the router, and then also configuring your PCs. All right, well, folks, that's all I got today. Next time you will see me will be in over a week. I head to Argentina on Saturday and will not be back till the next Saturday. So more than likely, I will not have any access to the internet and will not be checking emails very much during that time. So if you're in my class and have questions, send me an email and I'll try my best to get it. But if not, I will, you can also send it to Michael or Brian and they can answer. Karen, no, not fishing. I'm actually going hunting. It's on a 2.5-day dove, 2.5-day duck hunt that we've been trying to do, trying our best to do for the past 3 years. And obviously COVID has been in the way. Jafar, you asked, can I watch the videos offline? Yes, you can watch not offline. No, you have to be on YouTube. You have to be on YouTube to watch our videos. So but you could I guess you could download them. I think, I don't know if you can on YouTube or not. I can't remember. Used to be able to, but oh, not synchronous. Yes, Jafar. Yeah, you can watch them not synchronous. So yeah.
I have one question. So when we were in NetLab and we did the copy run start to save our configuration file, is it any way we can upload that file from that system? Just for, I would love to see what my configuration looked like other than after I close the reservation is over with.
There's a couple ways you can do it. First off, you can just do a show run.
Yeah.
And then, space all the way down through your config. Let me get all the way through it here. And then you can go up to the top and start right here. And I usually start right at host name. So you can just come down here and you can actually copy it. So you can copy selected text and then you can just put it in your own notepad. So then you type notepad and then dump it in a notepad and then you've got basically all the commands.
All right, perfect.
That's one way to do it. You also can, if you want to, you actually take the pod and you can save all devices and that will save it into a folder that's locally. But I like just putting them on notepad so I have it.
Right.
For me, that's probably the easiest way to do it.
No, thanks. That's exactly what I needed.
Okay. Yep. Same thing with the router. You just do a show run. And then I usually start right above the host name to get the commands I need. And so just go up here and copy and paste it out. That's the best way to do it. Okay. Any other questions?
I have a comment about a different lab.
Okay, go ahead, Ed. What you got?
At lab 11.10.1 on packet tracer.
Okay, let me go find that one. Okay, yeah, I can go ahead and I can probably guess what your question is. It's not giving you it's not giving you points.
Yeah, I figured out how to, I got it because I reversed the subnets, different one. It tells you to do it. So,
Right. It is, Packet Tracer is a lovely, lovely tool. It's also a very dumb tool. It is a computer, so it only understands exactly what it asks for. So in this particular one, again, if you don't follow exactly what it's saying, then it won't give you points. So, and remember on this one too, the other thing is, unlike what I'm going to teach you, which is I don't suggest using your /30s up in the high portions. They are teaching you that you should be using your first big subnet will be the first subnet in your range. So it's not the greatest. It's not the greatest thing. It's kind of hard to have it on a packet tracer, but it is, you know, it is a way to test your skills. So
I know I'm jumping ahead, but can I ask a question about that VLSM?
Yeah.
Never in my life have I seen that. I've done a lot of subnetting, but I've never subnetted a subnet. And I think I would have lost my job had I done that with some of my customers. Is this only done out on the area border routers, or?
No, it's done internally everywhere. I mean, you've done it. You just didn't know you were doing it, because if you were using /24 on a Class A network,
Right.
then
Yeah, we do that all the time, but it looks like they're doing within that same network a /24, /23.
Yep.
And we never did that.
Well, we do it all the time. We do it all the time in networks. So for instance, I'll give you a great example. Imagine this. Imagine, let me share my screen here. And I can pull my whiteboard up once I share it. I had this packet tracer up here, but let me open my whiteboard. Give me just a second. I'm going to show you a real world example, Stanley Community College example. Everything on my desk doing it. All right, so let me give a second. My whiteboard is still. Can y'all see the packet tracer over here?
Yes.
Yes.
Okay.
Yes.
All right, I'm going to show you a real world example. So I'm going to give you, and again, this is something we are going to cover. So they'll be talking, Michael and Brian will be talking about subnetting next week, and we'll be talking about it more when I get back. But let me show you this. So let's imagine that I give you the network, or you have this network, 10.0.0.0/8. That is, as you know, this is a Class A network, which is typically one network of a whole bunch of hosts, about 16 million hosts. Okay. On our network, here's what we do. Imagine you got multiple buildings, right? So here's the Patterson building. That's our main building. Here's the building I'm in, Whitley, WTC. Over here's another building, the Kelly building. That's not my building. It's Kelley. If I ever get super rich, I'm going to make the real Kelly building. All right. But what we've done on our network is everything in our building is 10. Let's just say 10.10.0.0/16. Okay, so our building's connected to the core right here. This building is 10.11.0.0/16, and it is connected to the core. Can y'all hear me?
Yes.
Okay, so now inside of this building we have different rooms. So we have WTC 110. So that network is 10.10.0/24, and then 10.10.122.0/24. So what we did was we took this massively big network, we subnetted it into this network with /16 so we could summarize. And then we subnetted that into smaller subnets to be used in the classroom. So you've been doing this all along. You just probably didn't realize you were doing it. So all we really did here is we just borrowed, you'll notice the first thing we did is we borrowed 8 bits from this, which gave us all the networks of 10.0.0.0/16, 10.1.0.0/16, 10.2.0.0/16, all the way down to 10.255.0.0/16. So we subnetted this into a bunch of subnets, and then we applied that here, and then we subnetted it again to go into the rooms. Now, I will say, in the real world, we don't typically then subnet this again, but sometimes we do things like we won't go to a full /24 on our wireless networks. We'll go to a /23 or /22 so that we have more hosts. So you've been doing it and you've done it before. You just may not have realized you were doing it. Okay.
I guess again, we used that layer 3 switch for $25,000 and did VLAN tagging. So I never saw it done this way.
Right. Well, even with the layer 3 switch, though, all you did was you broke them down into these subnets. And so you had VLAN 10. So, for us, this is exactly what we have here. In our network, we have VLAN 110, which is the 110 subnet, VLAN 122, which is the 122 subnet. So that's exactly what we have. It's just, again, we're just subnetting a subnet. We took that class A and we broke it all down into a class, what looks like a class B. And then we took that and broke it down to what looks like a class C, but we're really just borrowing subnetting from a subnet. It'll make more sense as we go along. When we get there, I think it'll make more sense. But VLSM is extremely common in the real world. Yeah, I mean, it's everywhere.
Yeah.
Go ahead, Michael.
I'm just gonna say we used to use at my previous job, we used to have to subnet a subnet all the time for our small doctor offices. So whenever a new office was put up, we would have to subnet, or either if that current office grew, then we would have to subnet to put them on a bigger address space without interfering with the next office that we done put on the subnet after them. So we used to have to break down subnets all the time.
So yeah, it's a very common thing in the real world. Very common.
Kelly, in the real world, is the subnetting basically done via VLSM?
Yes. Very rarely do you see now what I call classful subnetting. I still teach classful subnetting first, because I think you've got to understand networks with all the same mask across everything. You got to understand how you do a simple classful subnetting. But most of our networks today are classless, which means VLSM. And Quentin, I'll give you a call when we drop off and I run to the restaurant. I'll give you a call.
The main benefit of that is saving bandwidth?
Saving address space. That's the main
address space.
Yep, save address space. Because think about it, you don't want to use a /24 between on a point-to-point link.
Right.
Because you have 252 unused host addresses that you're never going to use. So it'd be a huge waste. You want to use a /30 on those point-to-point links.
Okay.
So one last question on that. So when you're using the VLSMs and you've gotten some of these subs of the subs, all right, so where is your gateway? Your gateway always has to be in the same subnet. So you're actually using a /23, but it's got to upload to something that's a /24.
No, it's a /23 address. It's still the same subnet. It's still the same network.
Where's the physical? But it's pointing to the same physical router.
Yeah, but it's just an IP address put on the interface.
So you got multiple interfaces that you've put into that router.
Yep. Let me show you a real quick example, and because I think you understand basic subnetting, I can show you a quick example that I think will clear up exactly what you're thinking about. So let's do this.
I don't know how the hops are working on that within the same router. It's
Well,
very confusing.
here's exactly how it works. So let's imagine this. Let's imagine we've got a router. So here's a router, and we got it connected to another router.
Your screen isn't sharing.
Okay, well,
Are you?
you mean you got to share your screen to make things show up? Come on now. Okay. All right. So we got this right here. So we got a switch. All right. We got a PC here. We got a switch over here. Okay. We got a PC here. All right. So I'm going to give you the address. I'm going to start with 192.168.12.0, which is my favorite subnet. My favorite subnet. Now I'm going to borrow 1 bit, which is going to make it a /25, which means my magic number is 128. So that means I break this down to 192.168.12.0 to 127 and 128 to 255. All right. You with me so far?
Yes.
Okay. So now I'm going to use one of these. I need to use one of these networks. So I'm going to take this network right here. Actually, I'm going to lie to you. I'm going to undo that. I'm going to take this network right here, and I'm going to put it on this interface right here. So on gig 001, I put the IP address 192.168.12.129/25, because the first usable address is where the IP addresses are either not all ones or all zeros, or the host bits are not all ones or all zeros. This address, the host bits are all zeros, so that's your subnet address. This address, the host bits are all ones, so that's your broadcast address.
Right.
So the usable addresses in this subnet are 129 to 254. So I put 129 here /25. Now, all the other hosts on this network can be anything from 129 to 254. So let's make this host right here 130/25. Okay. Then I'm going to take this network right here, and I'm going to borrow another bit /26, because I don't need that many hosts on this other side over here. My magic number at 26 is 64. So I break this 0 to 127 down to 0 to 63 and 64 to 127. All right. And I'm going to pull this out right here and use this on the other side. So I'm on this network right here. This gig 001 is going to be given the IP address of 192.168.12.65/26. That means this host right here can be .66/26 all the way up to 126, because 64 is the network ID, 127 is the broadcast ID. I got one left here. I only need 2 right here. So I'm going to keep subnetting this. So I'm going to go to /27, which makes this 0 to 31, 32 to 63. Okay, that's a 63. Then I'm going to go one more. I'm going to keep going /28, which makes this 0 to 15 and 16 to 31. And I'm going to cheat, and I'm going to go on down here. I got to come down here to /29, which is going to break this one down 0 to 7, 8 to 15. And then I'm going to go to this one is going to go to /30, which is 0 to 3 and 4 to 7. Now I'm going to pull that one out, and this right here on the gig 000 interface, gig and 000 interface. This is going to be 192.168.12.1/30, and this is going to be .2/30. So for all hosts on this network over here, okay, all hosts on this subnet, the default gateway is 129. For all hosts on this network over here, the default gateway is 12.65. In the middle, there is no default gateway because there's only 2 hosts, so you got to worry about it here. And that's how they know. You just pick the first IP address in the subnet. That's your router ID, or your router. That's what you assign to the router. And that's going to be default gateway for that subnet.
For all of the subnets of the subnet.
For all the subnets of that particular, of all the hosts, not subnets, all the hosts of that particular subnet. So
They're
all
gonna
the
have
hosts in 192.168.12. By the way, the network here, the actual network on this side is 192.168.12.128/25, because that's this network right here. This network is .64/26. This network is .0/30. So for all the hosts on this network, their default gateway is .129/25, which is very important. You got to use 255.255.255.128 on this side. Over here, you'd use 255.255.255.192. Does that help a little bit? See, we're still subnetting. We're using different length mask on different parts of our network. So this is variable length subnet masking, and we're just taking a subnet. You'll notice this subnet, this /25, I just borrowed another bit from it to get this subnet. Then I took this 0 to 63 and borrowed 4 more bits from it to get the /30 that gives me my 0 to 3.
I have a question for you, Kelly.
Go ahead, Tom.
In your VLSM example, you always took the top portion of the VLSM subnet. Do you always have to start with that one, or can you use any of them?
You can use any. What the curriculum actually teaches is this. The curriculum would have pulled this piece out first. It always does the biggest piece first. So it would have pulled this out and used that for its biggest network. I don't like to do that because I like for my, you'll notice my point-to-point links are always, for me, are going to be .0, .4, .8, .12, .16. I like to use that for my /30s because I can remember that easier. Okay.
Could you have gone farther and go to a /32 or no, or would
go
you
to a
want
32? The most you can go is /30, because you got to leave. The reason is you got to leave 2 bits because you got to have at least one 2 host bits to have a usable host.
That's right. That's right.
Yeah. So the curriculum will say always pull your biggest piece out from the bottom portion. I don't always do that. I usually pull mine from the next one up just because it's simpler for me.
What about on the certification exam? Which way would you?
Just watch what they ask you. Just pay attention. They're not going to ask you pretty much, they're not going to ask you a subnet question. They're going to ask you, are these 2 hosts in the same subnet? Is this appropriate? Why are these 2 items not communicating? So typically they'll just have something wrong with the subnet addressing. You're not going to actually be creating subnetting schemes.
Just troubleshooting. Okay.
Yeah, on the curriculum, or knowing that 2 devices are in the same network.
Thank you.
Yep. Any other questions? And that was just a little bit of a next week. Brian and Mike will be working on that. Make sure for next week, if you haven't done so already, make sure inside of our class, everyone, I know it's an older lecture, but I strongly recommend before next week watching my old lecture on network addressing and the lecture on the 7 holy steps of subnetting. This is actually chapter 6 from several curriculums ago, but it's still the same. So watch these 2 and make sure you've read module 11 before you come to class next week. All right. Any other questions? Okay, I'm gonna stop recording.